awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Alright, so now let's continue question 6b. Okay, so here we have a 200-gram object. It's connected to a spring and move along the x-axis in a simple harmonic motion. So this question is from chapter 7, Oscillations and Wave. Alright, about the origin, the position of the object is given by. So this is the equation of the simple harmonic motion where y is in centimeters and t is in seconds. So make sure awak tengok pada unit dia lah. Y is in centimeters and t is in seconds. Okay, so this is the equation of the simple harmonic motion. So remember, general equation. So let's write y equal to a sine omega t. Okay, but in the question given, so we have y equal to 0.5 sine 0.4 pi t. So from here we can know that amplitude is equal to 0.5 and then omega here is 0.4 pi. Okay, so now number 1, calculate the frequency of the motion. Okay, so frequency omega is equal to 2 pi f. Very easy. So frequency is equal to omega, kita dah tahu, which is 0.4 pi over 2 pi. So we can cancel pi. And then finally, frequency we can write as 0.2 Hertz. Okay, so finish this one. And then question number 2, velocity of the object at t is equal to 4 seconds. So we want to calculate the velocity, okay, at t is equal to 4 seconds. Means that, okay, you refer to the list of equations. So write equation of v in terms of time, alright. So we're gonna have a omega cos omega t. So equation ini telah diberi dalam you punya list of equations. So we just use, make sure your calculator in radian mode. Okay, so remember v is equal to a, okay, a is equal to 0.5. Okay, that one is in centimeter. Omega is 0.4 pi and then cos 0.4 pi times t. Okay, jadi bila you tekan calculator, make sure you tekan yang ini dulu. This one should be 1.6 pi. So baru tekan cos 1.6 pi and make sure your calculator in radian mode. Okay, so v finally equal to 0.194 centimeter per second. So if you want to change to meter, then it is equal to 1.94 times 10 power of negative 3 meter per second. Okay, so this is the answer. Okay, and then number 3. Okay, so number 3. Okay, we write equation of acceleration in terms of time. So a is equal to negative a omega squared sin omega t. Sama juga macam tadi lah. A is equal to negative 0.5 times that one 0.4 pi squared sin 0.4 pi t. Okay, t itu boleh gantilah, which is equal to 4. Okay, so tekan calculator, pastikan dalam radian mode. So acceleration you akan dapat 0.751 centimeter sebab amplitude kita dalam centimeter. So unit dia centimeter per second squared. So if you want to change to meter, so it is equal to 7.51 exponent negative 3 meter per second squared. Okay, so this is the answer for question number 3. And the last one, this is very easy, the total energy. So the equation is half Ka squared. Ataupun awak boleh tukarlah K ini kepada m omega squared, where K is equal to m omega squared. Therefore, E, the total energy of the system, half, and then the mass is 200 gram, which is 0.2 kg. And then the amplitude, ingat bila you nak kira total energy, pastikan amplitude awak tu dalam meter lah. Sebab energy unit dia joule, so pastikan amplitude dalam SI unit, which is meter. Alright, so the amplitude tadi 0.5, so make sure you change to m omega dulu. Mass dia, and then omega 0.4 pi squared. And then times amplitude 0.5. So dia akan jadi 0.5 cm kepada meter lah. Power of negative 2 Power of negative 2 squared. Okay. And then the answer is equal to 3.95 exponent negative 6 joule. Okay. So this is the answer for question number 4. Alright. So now let's look at another question. Okay, which is question C. Tadi 6B. So sekarang question C. Alright, question number 6C. Figure 4A shows a graph of displacement Y versus time T. Okay, so in this figure, so here we have Y against T graph. Okay, and then Y against distance graph, YX. So YT, and then, and then YX. Okay, so bila you ada dua graph macam ni, remember if you have a graph of Y against T, okay, so this is the amplitude, sama lah, Y against X pun sama, ini adalah dia punya nilai amplitude. But, look at the X axis, okay, for graph Y against T, okay, we can determine the period of the oscillation. Okay, for example here, so this is half oscillation, and this is one complete oscillation. So for one complete oscillation, we can determine the period of the oscillation from Y against T graph. Okay, so kalau kat situ dia bagi 6, so sini mesti 4 lah. So sini mesti 2 dan 8. So from here we know that T is equal to 4 second. Okay, ini maklumat yang kita dapat lah. And then from graph Y against X, okay, so this is one wavelength, half oscillation, and this is for one complete oscillation. So kalau sini dia bagi 7.5, so means that here is 2.5, and here is 5.0. Okay, so daripada sini kita dapat maklumat kalau graph Y against X, remember kita mesti dapat maklumat wavelength, where lambda is equal to 5 cm. Okay, so pandai baca graph, so keluarkan maklumat yang penting lah. Alright, and then from the graph given, so question asks us to determine the wave number. Means that K is equal to 2 pi over lambda. This is very important. Okay, untuk awak faham lah bagaimana nak dapatkan bacaan untuk lambda wavelength. Okay. Alright, so K is equal to 2 pi over lambda, where lambda is equal to 5 cm. So if you substitute here, so that one lambda is in centimeter. If you want to change to meter pun boleh lah. Okay, so 2 pi over 5. So kat sini saya dapat dalam sentimeter 0.4 pi per centimeter. Kalau you nak tukar dalam decimal point pun okay, tak ada masalah. Okay, and then the wave propagation, which is the velocity, okay, we want to find V is equal to F lambda. Okay, lambda kita tak ada masalah lah, kita ada. Tapi frekuensi kita boleh cari daripada period. Okay, where frequency is equal to 1 over T. So that one is the formula for frequency. Therefore, frequency is equal to 1 over T times lambda. Okay, so the period is equal to 4 seconds. Sebab tu penting lah kita nak tahu kan berapa dia punya dia punya period tadi. Darab 5 cm. So you kira lah V you akan dapat itu saya akan dapat V is equal to 1.25 1.25 centimeter per second. Okay. So, ini jawapan untuk soalan nombor 2 lah. Okay. And then the last one, the displacement and the velocity of the particle at 2 centimeter and t equal to 2 second. Alright. So now the equation. So we need to write the equation of the progressive wave here. Okay, where y is equal to a. So ini adalah general equation dia lah. Sin omega t. Alright, so since you look at here that v is to the left. Okay, kat situ dia dah tunjuk v to the left. So must be positive. Kx. Okay, and then y. So amplitude is equal to 2 cm. Sin omega kita tadi. Kita kena kira lah. Kan, omega is equal to 2 pi over t. Omega tu kira 2 pi over t, which is 2 pi over 4 lah. Okay, 4t. So, yang ni awak boleh potong. Kalau nak potong, dia akan jadi pi over 2. Okay. And then plus k. K kita dah kira tadi 2 pi over 5x. Ini semua y and x in centimeter and t is in seconds. So, y is equal to 2 sin pi over 2 and t dia bagi situ 2 second plus 2 pi over 2 pi over 5 and x is 2 centimeter. Okay, so yang boleh cancel, make sure your calculator in radian mode. Okay, saya dah pesan banyak kali lah. So, jangan salah. Okay, so mana yang kita boleh cancel tu kita cancel. So, akhirnya you akan dapat y is equal to negative 1.18 cm. Bukan meter sebab tadi semua kita punya k dalam per centimeter. So kita punya x ni pun kita masuk centimeter. So y ni mesti dalam centimeter. Okay. So finish question 6C. So let's proceed to question 7. Alright, question 7. Okay, look at here. We have a metal wire, 1.2 millimeter diameter, and then 3 meter length is stretched by a force of various magnitude. So, the stress against strain graph is shown in this figure. So, based on this figure, make sure you check, okay, the label of axis, okay, for x-axis and also the y-axis. Make sure you include, okay, in the calculation. Alright, okay. Okay, so now the diameter of the metal wire, so given that D is equal to 1.2 millimeter, means that the radius, okay, saya lagi suka tukar terus kepada radius lah, is equal to 0.6 times 10 power of negative 3 meter. And then the initial length, L0 of the metal wire is given 3 meter. Okay, so semua kita dah tukar kepada SI unit. Okay, so this is start from 0. So, if the strain, you can see here, if the strain is equal to 1.5 exponent negative 3, strain tak ada unit stress dia adalah equal to 10.5 times 10 power of 7 Pascal. Okay, so question number 1. Okay, calculate the Young modulus of the metal wire. So, this is very easy since Young modulus is actually we can write kalau awak faham definition of Young modulus, it is actually the ratio between the stress over strain. Okay, Young modulus is the ratio between stress and strain. So based on the graph of stress against strain, so kalau kita kira the gradient of the graph M, kan, dia adalah paksi Y bagi dengan paksi X, Y axis over X axis. So dia akan jadi stress over strain lah. Okay. So, ini saya tulis ni. Strain. Okay. Stress over strain. So, ini stress over strain ni adalah the gradient of the graph. Okay. Gradient of the graph. So, kita boleh terus kira lah gradient of the graph. Where Y is equal to 1.5. Okay. Sorry, 10.5. Okay. Y axis 10.5 exponent 7 over 1.5, the stress is exponent negative 3. Okay, so finally, Young modulus, jangan lupa ya, unit. Okay, 7 times 10 power of 10 Newton meters per meter squared. So this is the answer. And then number 2, what is the applied force if the stress of the wire is 10.5 times 10 power of 7 Pascal? So we want to determine the applied force. Okay, so based on equation of stress, kita boleh keluarkan, okay, force over area, the cross-sectional area. So the cross-sectional area is not given, which is pi r squared. Area is pi r squared. Okay, so daripada situ boleh carilah the applied force on the wire is stress times A. So stress dia kata kalau stress dia adalah 0.5 exponent 7 and then pi r dia tadi adalah saya dah tukar kepada meter, power of negative 3 squared. Okay, and then the force is equal to 118.75 Newton. So this is the answer for question B. Sorry, 7.2. And then the last one, determine the strain energy stored. Okay, this means U, okay, in the wire if the strain is 1.5 exponent negative 3. Alright, so now for question number 3, we want to find U. Okay, tapi dekat sini you kena faham sikit. Okay, kalau kita ada graph stress against strain, remember, the area under the graph, okay, ingat kalau you ada graph stress against strain, the area under the graph here will give you the value of energy per volume. Ini akan bagi you U over V. Tapi soalan tak minta U over V. Soalan minta awak kira dia punya, apa nama ni, punya U lah. Okay. So, since U over V is equal to, okay, area under the graph. So, untuk you dapatkan U, dia akan jadi area under the graph. Okay, darab dengan V lah. Okay, so area under the graph, you kira triangle. Okay, the area of the triangle, which is 1.5 exponent negative 3 times 10.5 exponent 7. And then the volume. So, how to calculate the volume of the cylinder? So, to calculate the volume of a cylinder, remember, ini kena tahulah knowledge awak pi r squared h. H dekat sini the height lah. So, kalau wire tu kita consider as a cylinder macam ni. Kan? So, panjang dia adalah tinggi dia lah. So, this is the height, which is the length is given 3 meter. Remember? Okay? So, R kita dah tahu tadi. So, we just substitute. Okay, you substitute lah. Okay, nilai R ni adalah, berapa tadi? 0.6, right? 0.6 exponent negative 3 squared. Okay? And then H here is 3 meter. So, you substitute all the values. So, finally, you can find U is equal to 0.27 joule. Alright, so this question I think is very interesting. Since from the graph of stress against strain, awak tak akan dapat U. Tapi awak akan dapat energy per volume, U over V. Tapi soalan minta U, so awak kena darabkanlah area under the graph, okay, times the volume, okay, volume of the cylinder shape, which is pi r squared over H. So, saya rasa kalau masalah student tak boleh jawab ni, kalau you tak teringat, what is the formula untuk volume, untuk cylinder shape. Okay, so boleh buatlah yang tu. Alright, so now finish question 7. Okay, the last one, question number 8. Okay, so the molar mass of oxygen. So we try to take out all the informations given. Okay, so for A, so we have the molar mass of the oxygen. Okay, I will convert to kg per mole, 0.032 kg per mole. And then the temperature is 300 Kelvin. So, calculate the root mean square speed of the oxygen. This is very easy. The question is really straightforward. Okay. So, you can just straightly use the equation of root mean square speed, where VRMS is equal to square root. Okay. Square root apa? 3RT. Sebab kita ada temperature and then the molar mass. So, ini masuk guna formula saja. Very easy. Okay, make sure the temperature kalau dia bagi dalam degree Celsius, you change to Kelvin. And then the molar mass, make sure in kilogram per mole. So the answer is equal to 483.44 meter per second. Unit jangan lupa And then second, internal energy of 3 moles oxygen. So N is equal to 3. So you want to find U. So F over 2 nRT. Okay, so F tu you masukkanlah. Oxygen is the diatomic. Okay, so the degree of freedom F must be 2 times 3, 8.31. And then the temperature is 300 Kelvin. And then the last one, U, okay, must be in joule. 1.87, okay, times 10 power of 4 joule. Okay, so finish that one. Alright, and then proceed to B. B, okay. A 1.5 moles of ideal monoatomic gas is initially at temperature 30 degrees Celsius. So N is equal to 1.5. T initial is equal to 30 degrees Celsius plus 273.15. Okay, so you can change the temperature to Kelvin. So it will equal to 303.15 Kelvin. And then the pressure, the initial pressure is 1 atm. Okay, awak check dekat depan in the list of constant dekat depan kertas soalan. 1 atm you tukar kepada Pascal. Siap-siap. Boleh So pressure tu 1, okay, 1 times 1.013 exponent 5 Pascal. Okay, which is 1.013 exponent 5 Pascal lah. Boleh Okay. And then sketch the graph. The gas undergoes isothermal expansion to double its original volume. Okay. So V0 kita tak tahulah berapa. Okay. So V0 kita tak tahu. Tapi kalau nak kira, sebenarnya kita boleh kira lah V0 tu berapa. Sebab semua maklumat kita dah ada. Kita boleh guna formula. Kalau you nak kira boleh. PV is equal to nRT. Kan? N you ada, R you ada, temperature you ada, pressure you dah ada. Then actually you can find what is the volume, initial volume V. Okay? So V final is given 2 times V0. So the process is isothermal process, constant temperature. So when you want to sketch the graph, remember. So for PV graph, make sure you have the unit here. Okay. And then this one, okay, which is V, must be in meter cube. Alright. And then this one start from 0. So let's say at the pressure of 1.013 exponent 5, okay, the volume is V0. Kita tak tahu berapa. Somewhere here. Okay. So the process, let's say the process start from A. And then untuk isothermal process, make sure dia atas line of the temperature yang sama. Okay, T. Contoh ni T dia samalah. Constant temperature. Okay, so letaklah B kat sini. Which is 2B. Okay, di mana volume kat sini kita tak tahu berapa. Okay, so this one should be PB. Okay, kalau you nak kira sebenarnya boleh je. Okay, guna equation for equation of Boyle's law, isothermal. So 2V0. Okay, so kalau you rasa you nak kira, boleh kira V0. Okay, kalau you nak kira V0, let's say lah you nak kira kan. So dah akan jadi V0 is equal to nRT0 over P0. So dah akan jadi 1.5, 8.31, and then the temperature is 303.15. Okay, over P0 is 1.013 exponent 5. Therefore, V0 ataupun V dekat point A tu you akan dapat. Okay, so V0 is 0.037 meter cube. So, kalau 2V0 dah akan darat 2 lah. 0.037 times 2. So, somewhere here 0.074 and here 0.037. So, in case lah kalau you nak cari pressure at point B ni boleh juga. Okay, you guna equation of the Boyle's law, which is isothermal process. So, dia akan jadi PA VA equal to PB VB. So disebabkan semua you dah ada, PA ada, VA ada, VB pun dah ada tadi kan. 0.074 dan you can find lah PB. Okay, tak ada masalah. Alright, so now settle number 1 and then calculate the work done by the gas. Okay, so this is isothermal process. So remember, equation of isothermal process, W is equal to nRT ln V final over V initial. Okay, V final tadi 2 kali ganda V initial. So, kalau you tak kira pun volume dekat point B dan point A tu, tak ada masalah. You boleh kira juga. Okay, 8.31 nanti boleh cancel lah. T is 303.15 ln V final is 2 V naught. And then V initial, which is V at point A tadi adalah V naught, right? So, now you can cancel V naught. Okay, very easy. So, the answer of W, make sure you write the correct unit. 2.62 exponent 3 joule. Okay, so this is the answer. Okay, next. Calculate the change of the internal energy. Yang ni tak payah kira. Okay, awak kenapa? Sebab untuk isothermal process, kalau you dah hafal, you dah ingat, okay, T is constant, right? So, equation of the delta U will equal to F over 2 NR delta T. So, you can see here that delta U depends on the temperature. So, if the T is constant, so means that delta T ni akan jadi kosong. So, kalau delta T tu kosong, yang lain ni semua constant. So, delta U is equal to 0 joule. Okay? And the last one, the heat absorbed by the gas. So, we want to calculate Q. So, use the first law of thermodynamics equation. Delta U is equal to Q minus W. So, remember, equation dah ada dah kat depan. You pakai je semula. Okay. So, delta U for the isothermal process. Delta U is equal to 0. Okay. And then, Q equal to W. So, kita dah kira W tadi kan. So, this one 0. So, Q minus W. Therefore, Q is equal to W. And Q is equal to, kita dah kira dah tadi, 2.62 exponent 3 joule. So, this is the answer. Okay. So, we finish set 3. So, see you in the next video. Okay, mungkin kita akan discuss untuk set 4 pula. Alright, so all the best and good luck. Jumpa lagi. Assalamualaikum. Bye-bye.